Hello students, welcome you for the second chapter, that is work, energy and power. This is the continuation part what you have studied in your 8th standard. Even in your 8th standard you had a concept of work, power, energy. In the energy chapter we have been studying. So in the 10th standard we will detailedly study about what are the expressions for work, what are the special cases, what are the SI units, CGS unit, bigger units, smaller units, when the work is considered to be zero, all these situations including energy and power. So without much wasting the time, let us come to the actual topic. What do you mean by work? This work or word work is being heard in our daily home activities. Right? Everywhere you use the word work. When two people start speaking of something, like you tell, I had some work, I had to go somewhere. Why you have come to this place? If your friend asks you had been visited this village, then you will utter a word, I had some work. Everywhere the word comes, word. But what actually the meaning of work? See here. In our daily life, the word work is used for some sort of exertion that may be both physical or mental. For example, let us keep on listing the amount of works what we have been doing or the types of work. For example, you will be eating your friends just call you for a while to ask you how you are doing in this time situation. When you receive your phone, you will just ask what work you are doing. You may tell that you are eating. Since you are eating, then let me consider first one is eating. Right. Next, you was writing something, the notes of some subject. Some neighbors has been displayed in your home. They ask you the neighbors what you are doing. You will just what work you are doing. They ask you just that you are writing. Reading, writing, all these types of works. Then whatever, for example, you are watching a TV, television, you just say. If someone asks your mother what you have been doing, you just say, I am watching TV, watching. See, all these cases we consider to be as a work. If we are not that we are moving somewhere or anywhere, even if we are eating, we consider it to be a work. Even if we are writing, we consider it to be a work. Even if we are eating, that is also considered to be a work. Writing, eating, standing. Why not other thing? If I am just standing here and delivering your lecture, I just said it is also considered to be a work according to our common language. But the question arises now is, do we think in physics, this same three things what we have written here as an example, can we consider a work? That is the question. We have got this answer even in your 8th standard, because according to physics, the word work is being done. The word work is being done. Only when a body moves. Only when a body moves or displays. Body moves or displays under the action of force. Under the action of force. So what do you mean by this? Here I will highlight force. Body moves or displays. What do you mean by this in a physics? According to physics, work is being considered to be done only when a body should be keep on moving. And how can a body move? Body move under the action of force. When you apply a force itself, a body moves. Now come back to the examples what we have taken. Eating, writing and watching. In these three cases, can you see the body is being keep on moving? Means consider you yourself as a body here. Don't use your hand like for eating and all. We are not considering that. So like maybe eating or writing or watching. There is no force which is being acting on you and you are not getting displaced. Hence, this writing, watching, standing, sitting, all those things in our common day-to-day life we consider it to be a work. But according to physics, when we are looking, but all the things which is being not displayed is never going to consider to be as a work. then what is going to consider to be a work according to physics? According to physics, the word work is being done only when what? When a body moves under the action of force. To take this a better example, let us consider a table. We have a table. On a table we have a book being placed. There is a book on a table. So you had come to a table, took this book from this place and sat on some chair here and started reading. This example is considered to be a work according to physics. How? Because I told you, according to physics, a force should act on a body and the body should get displaced. Both is being happening. See, you are applying external force here, right? You are applying external force to take a book from there. Taking Newton's laws of motion. Before it was in an inertia, state of inertia. Which was the state of inertia? Inertia of rest. When you keep on applying the force, what happens? You took a book and the book got displaced. Now come back here. Work is being done only when a body moves or displaced. Here body is a book. It is getting displaced. When it is getting displaced, it is getting displaced only when you are under the action of force. Under the action of force. Then we can consider this is being an example of what you mean by work according to physics. Understand? One more example also you can take, like pushing a car. Pushing a car. Have you ever tried? We have some friends who keep on moving somewhere in a car. Like you got some repair or it is not able to move it in a up. So what are the examples you can do that? You all get out of the car and start pushing, one will be driving. So you are able to push a car. When you are pushing a car, what is happening? When you are pushing a car, you are applying a force. No, you all are applying a force. And this car is getting displaced. Is it not? Car is getting displaced. Look at here. You are applying a force, it is getting displaced. So the condition satisfies with the physics. According to physics, what is our plan? Force should be applied and a body should be displaced. Hence, we can consider pushing a car is also an example considered to be a work. Now, we have to consider some condition 1 or see. If you apply a force itself is not enough. If you apply a force itself is not considered to be a work. Is not considered to be a work done. Is not considered to be a work done. Even the body should be displaced. Even the body should be displaced. Why am I telling that? Because let me take an example so that you will understand. Pushing the wall. Pushing the wall. Or second example, let me consider. Child tries to move. Child tries to move heavy stone. These are the two examples, and already I know according to physics, a work is being done only when a force is being applied and a body is displaced. In this condition, look at here, when you apply a force itself is not considered to be a work done. Even the body should be displaced, then only it is considered to be a work. No doubt, pushing a wall, you keep on trying to push a wall for years and years, you are not at all able to move a wall. In turn, you are applying a force, no doubt. But does the wall is being displaced? No. It is in the same place where it is. So even after you lose the energy of keep on pushing it, still that didn't. What do you mean by a wall is not moving? It is not considered to be a work done at all. It's a very strange, but that is a fact according to physics. So what does the physics tell? If work is being done, you should apply a force. Body also should get displaced. The other example I have taken. Child tries to move a heavy stone. There was a heavy Can he or she move it a stone? They are not able to move a stone, right? So means they are applying the force, but the body or the stone, it is not able to get displaced. Hence we consider this is also not considered to be a work done according to physics. So we have understood one fact. So according, how can we define this work done? Work done can be defined. Work done can be defined as. Work done can be defined as the force. The force should be applied. The force should be applied. The force should be applied on the body. The force should be applied on the body, and the body should be displaced. The body should be displaced. The body should be displaced. So this is the work done according to what? According to physics. This we are going to consider to be that. Only in this situation we consider the work has been done according to physics. Otherwise it is not at all. Like eating, writing, no doubt. In a day-to-day life we consider all those sort of work. Even after teaching you this topic of work done, I myself when I go to home or my friends call to me, what work you are doing? I just said I am eating. That's a common day-to-day life how we are dealing of. But according to physics, when you are speaking, a work is being done only when you are applying a force, the body should also get displaced. Then only, let's see, this is also a situation. Here also we consider work is not being done. Only if you apply a force is not at all enough. If the body also should what? Displace. Means work done is equals to force into displacement. There should be force also, there should be a displacement also. For example, now you had, in the case of pushing the wall, you had applying a 10 Newton of force, but displacement is 0 because it is not at all displaced. So this 10 zeros are how much? 0. That is the reason we consider work done to be what? 0. The same situation even in the case of, what do you mean by child tries to do the heavy stone? If displacement is 0, work done itself is 0. Understand? So for work done, both force and displacements are very important. Now let us go and see that what you mean by measurement of work. How do we measure work? Then we have some conditions for the work done. We will see that. Now we will see that how can we measure a given work. So to do that, I have considered two cases. See, in a case one, I have taken a tennis ball and football. Here, think that on a tennis ball, I am applying a 5 Newton of force. Upon a football, I am applying a 10 Newton of force. Just take as an example. Now, this tennis ball had moved to the distance of, had covered a displacement of, for example, 10 meter. Football also covered a displacement of 10 meter. Can you see here? For example, think that force A. This is force B. This is displacement A, displacement B. Means understand the situation. I have taken two different bodies. One is tennis ball, one is football. When I apply the force of 5 Newton on tennis ball, 10 Newton on football, but both have been covered same displacement. That is 10 meter, 10 meter. Now, where do you think the work done is more? Is work done on tennis ball is more or work done on football is more? That we have to find it out now. That is, we know that work done is equals to force into displacement, right? Now, in the case of work done A, this is, that is force on A, displacement. So, what is the force applied in the case of A? Force applied is 5 Newton. So, what is the displacement caused? It is 10 meter. So, 10 by 50 Newton meter. This is the work done in the case of A. Now we have to see work done on an object B, that is football. So again FB into displacement to be B. So work done on B Now, whether the work done on football is more or tennis ball is more, obviously the work done on B is greater than work done on A. Understand? See, in a case 1, I have changed the forces and keep the same displacement. But I understood by keeping the displacement same, if I change the force, again the work done is going to be changes. Understand? Now let us see case 2. In a case 2, I am considering again the same two bodies. Okay. For example, here I am applying force A to be 10 Newton. Here also I am considering force applied on is also 10 Newton. It is getting displaced to, for example, 10 meter. This is getting displaced to 15 meter. Now let us see work done on which is being greater. Just give some name, object A, this is A and this is B. No need to give the names of anything. We have to understand the concept here. So now work done on A, force into displacement. So what is the force? 10 Newton. Here displacement also is 10 meter and then the 100 Newton meter. This is work done on A. Work done on B is so much, that is force B into displacement B. Force applied is again 10 Newton, but displacement is 15 meter. So 15 is 150 Newton meter. So here also work done on B object is greater than A. Work done on B is greater than A. Here what did I keep saying? I kept force as constant and I have changed what? Displacement. Here I have changed the force and keep displacement constant. So by this what did we understand? Above from these two cases, see, work done is equals to what? Force and displacement. Means work done is directly proportional to force, work done is directly proportional to displacement. Understand? Means in case 1, here in case 1, amount force and displacement. See here, I have kept displacement to be constant and changed the force 5 and 10. But still I can see work done depends on what? Force. So only I came to know the work done on football is greater than tennis ball. In case 2, what is the expression if I take W is equals to force into displacement? I kept force as constant and changed the displacement like 10 and 50. So by that also I came to know by changing the displacement, keeping the force constant, still work done changes. So by this what we understand? Work done depends on the work done depends on the factors. The work done depends on the factors. First one, the magnitude of the force applied. The magnitude of the force applied. The magnitude of the force applied. Then what is the second one? The displacement. The displacement caused by understand? These are the two conditions on which work done is defined. See, magnitude of force. You have changed the magnitude 5 Newton and 10 Newton. Means work done is depending on magnitude of force what you are applying. And even work done is depending upon what? Work done is depending on the displacement. Oh, sorry, this displacement. Displacement caused by the applied force. Understand? Displacement is denoted with the letter S. Therefore, you show it's a vector point. Understand? The magnitude of the force. So we came to know that mathematically we can tell. For example, I have considered a body. You are applying a force in this direction, and the body is also displaced in this direction. Means You are applying the force also north, south, east and west. You are applying the force also towards east. You are applying the force also towards east, and the displacement caused by an object is also towards where? Towards east. Then what is the expression for the work done? Work done expression is W is equals to F into S, where W is work, F is force, and S is the displacement. Means this is the expression only when you are applying the force also in the same direction and the displacement also is happening in the same direction. Because from the next classes we are going to see that when you are applying a force in one direction, the displacement causes other direction. Then we need to take something called, along with F into S, we need to consider what you mean by cos theta. This comes from your next classes, I will explain you. For until this class, remember that when you apply a force and a displacement, both are in the same direction, then this is the expression. Understand? That is F W is equals to F into S, where W is work done, F is a force, and S is a displacement. And one more thing we need to understand, work is a scalar quantity. Work is very important. Work is a scalar quantity. Understand? Work is a scalar quantity. Why it is a scalar quantity? Work has only magnitude, but it doesn't have a direction. Remember, it's very important. And did you understand the measurement about how can we measure a work? We can measure a work by knowing the force and displacement. Here both work done is directly proportional to force and displacement. If force increases, work done increases. Look here, force increases, work done increases. If displacement increases, work done increases. Both are equally. And we had last class we came to know that. For example, pushing a wall. In the case of a pushing a wall, you have force, but displacement is 0. So at that time, work done is also how much? Work done is 0. Understand? So for work done to happen, we should have both force and displacement. When you are eating, you have some force, but what is it getting displaced? You are getting displaced. When you are watching a TV, is TV getting displaced or you yourself getting? No. So according to this, if work done, we have to consider both force and displacement. Understand? See, a work, energy, power chapter, work is a scalar, energy is a scalar, power is a scalar. This is a chapter of entire scalar quantities. You should know to differentiate which is a scalar and which is a vector. Now, for example, work done, right? We are considering what is the SI unit of force? SI unit of force is Newton. What is the displacement? Meter. Newton meter is also a SI unit of force. SI unit. But instead of Newton meter, if you write it as what you mean by joule. Joule is a SI unit of what you mean by work done. That is J. Understand? This is the SI unit, and what is the CGS unit is dyne centimeter. Dyne centimeter is the CGS unit of work. Newton meter is the SI unit, and even you can call it as what you mean by joule. Understand? So till now we have studied what you mean by measurement of work, and today we have given a brief introduction which is considered to be a work, which is not considered to be a work according to physics. And we have understood the expression for work when you are applying the force is also in the same direction and the displacement is also causing in the same direction. Then we have work done expression to be F into S. In the next class we will see in a detailed study that when you are applying a force in one direction, that is when you apply a force in this direction, if displacement causes in this direction, understand, if it is not causing here, actually now we have done when you are applying a force here, displacement also is going in this direction. In turn, if displacement happens in this direction, how do we take an expression of work done, or how do we measure the work? Here easily we have measured a work, force and displacement, but in this case, how to measure a work? What are the things we need to take? That we will study in the next class. And there are special cases we need to understand for a work done. Very interestingly, this chapter keeps on goes, and it's a very easy chapter and an important chapter to score mark in your ICSE. Numerical is 100% in this. Understand? So until then, we will see you in your next class. Until then, take care.